We are currently multiplying, and I wanted to show a method that one of my students said that they learned, and it seems to be helping students that are struggling with multiplying. So I teach middle school, and we are currently learning how to multiply and divide integers. So for example, if we had a number like 79 and 82, what we could do, you could say 79 times 82. This is the traditional way that I learn. My students are using a box method. So with this box method, they put one number on the top and one number on the right side. And then they divide each box in half diagonally. And the top part is the tens place and the bottom part is the ones place. So they're going to multiply each number. So this cuts down the number of numbers they need to know how to multiply. They really need to know their facts from 0 to 9. So they would say 8 times 9 or 9 times 8 and get 72. And then 9 times 2 and get 18. And then 7 times 8 and get 56. And then 7 times 2 and get 14. From here, what they're going to do is add along each diagonal. So in this diagonal, it's only the number 8. So from here, they would add 2 plus 1 plus 4 and get 7. On this diagonal, they have 7 plus 6 plus 1, and this is going to give us 14. So we're not going to write 14 here. What we're going to do is just like with regular addition, we're going to put down the 4 and carry the 1. So the 1 is going to come up here. So 1 plus 5 is 6. So then we're going to put this together from left to right. So 6,478. Now, if we multiplied it with the stack, we would get the same answer. So let's multiply it with the stack. 9 times 2 is 18. So put down the 8, carry the 1. 2 times 7 is 14, plus 1 is 15. Now I'm going to place the 0. 8 times 9 is 72. So put down the 2, carry the 7. 8 times 7 is 56. And then 56 plus 7 is 63. And then we're going to add. So we have 8, 7, 4, 6, and you get the same answer. So now what happens if our numbers are not the same amount? So if one of our problems has 3 numbers and the other one has 2 numbers, for example. So with this, you still set up your table. You put one number on top and one number on the right side. So if my number was 125, and then times 16, again, I'm going to cut my tables diagonally. And then I'm going to go through and multiply. So 5 times 1 is 5. So there's no tens here. So I'm going to put down a 0 because there's nothing in the tens place. 5 times 6 is 30. 2 times 1 is 2. 2 times 6 is 12. 1 times 1 is 1. 1 times 6 is 6. So each time I didn't have a number in the tens place, I put in a 0. And then I will go through along each diagonal and add. So I have 0. 5 plus 3 plus 2 is going to be 10. So I put down a 0, carry that 1 like we would. 1 plus 0 plus 2 plus 1 plus 6 is again 10. And then 1 plus 0 plus 1 plus 0 is 2. And then we have nothing up here. So when I write this number, if your students just directly copy it, this looks weird. So just remind them, this 0 right here, we don't need it. We just have 2,000. So just to show it's the same thing, if we do the stack multiplication, 125 times 16, 6 times 5 is 30. 6 times 2 is 12, plus 3 more is 15. 6 times 1 is 6, plus 1 more is 7. And then place down a 0. 1 times 5 is 5. 1 times 2 is 2. And then 1 times 1 is 1. So add them together, 0. We get 10. We get 10, and then we get 2. So we get 2,000. So if your students are struggling with this stack multiplication, I would recommend giving these tables a try. They seem to be really helping if students know their multiplication facts from 0 to 9. It seems to be helping, especially if students forget to place that 0 down when they are multiplying larger numbers.